हेलो माय डियर स्टूडेंट्स, गुड मॉर्निंग, गॉड ब्लेस यू, अस्सलाम वालेकुम। कैसे हैं आप लोग? आज मैंने आपको एक न्यू टॉपिक पढ़ाना है एंड टुडेज टॉपिक इज़ अगेन related to kinetic particle theory, and today we will discuss in detail the physical process freezing, how it happens, when it happens, and what are those conditions which are visible during freezing. So let us continue with the learning objectives. The learning objectives for today's lesson are: we will know about freezing, we will know about boiling, and what is the role of heat during the interconversions of states of matter while freezing and boiling. And we will also get command on the change of what is the change of particles in terms of their kinetic energy or in terms of their intermolecular forces. And we will also be learning how to draw the temperature curves. So let us begin with a very simple defined definition of freezing. Freezing is the process by which a substance changes from a liquid to a solid. So you see, when it's a physical change, a very important thing to know, that the matter remains the same, the composition remains the same, only one form of matter, the liquid, the solid, is formed from its liquid phase. So we see the freezing is a physical change when a substance changes from a liquid to a solid. The next thing, the question arises in the mind that what are the changes between this freezing process? What happens to the particles? You see, when the particles are in liquid phase, you see, when we heat up the particles of a liquid, it becomes gigantic. But what happens when we cool? When we cool a liquid, the energy comes out. So this happens when the temperature of the liquid drops down, so it starts settling and arranging them, and the kinetic energy of the particles drops down, and this results in their ordered arrangement. So we see the liquid is freezing. So during freezing, the very important point, the energy comes out. It's not a heating process, as it is a cooling process. And when the energy comes out of the liquid particles, they start solidifying. So they come closer. They are coming to some ordered arrangement, as the distance is also getting minimized. So they come closer, and this increases the binding forces among atoms. So what is next to know? When we cool a liquid, it freezes. That's very obvious. And the temperature at which any liquid is turning into its solid is called as its freezing point. So we can never ignore this very important constant, that's freezing point. So what is a freezing point? The temperature, it's the temperature at which a liquid becomes solid. Okay, and we often measure it in degrees Celsius. So the very important thing is it is a fixed temperature, means every liquid freezes at a sharp, fixed, unique, its own freezing point. Now what happens normally when we cool a liquid? What happens? Now we will today again repeat the temperature curve. Now this temperature curve is basically the graph between temperature versus time. So you can see on y-axis we have plotted the temperature, and on x-axis we have plotted the time. So it is a temperature curve. Now this time we are cooling a liquid, that's why we can call it as cooling curve. Okay, the sample again, the naphthalene. When we heated naphthalene, the temperature rose, but when we cool naphthalene, you can see the temperature of the sample is dropping down. At level P, the temperature is high, but as we continue cooling, the temperature of naphthalene drops down until it reaches point Q. So from P to Q, the noticeable change is that temperature is dropping down during cooling. And the change between Q and R, everyone can see that this is the phase when temperature is not changing. So this is the phase when temperature remains the constants, and this is the transition when the liquid is settling down on freezing down to a solid state. So on further cooling after R, the temperature again drops down. So this is the phase in which all the liquid has solidified, and the temperature of the naphthalene drops as the cooling continues. So we got to know that this heating curve explains enough about the temperature change when the phase changes. Remember that whenever the physical state changes for a while, for some time, temperature remains constant, and we get the idea of its observation. Thus we wait for the stage when the temperature remains unchanged for a while, and it is 80 degrees Celsius. So we got to know that the freezing point of naphthalene is 80 degrees Celsius. Okay, now we continue to understand another topic which is discussed in kinetic particle theory. Now this time we will learn that what is boiling. Very obvious change when we heat liquid or substances during cooking. The vapors come out, the clouds are formed, and these are the vapors. So in this picture I am showing you that when water is heated on stove, it starts boiling. So this is the change which is between liquid to gas state. And the learning outcomes or the objectives for this topic is that what is boiling, what will be the temperature change, what will happen to the particles during this change, and how we can draw it on the graph, means how we can draw the temperature curve for boiling process. So here we begin with the very simple words which are defining it. So boiling is the process by which a substance changes from a liquid to a gas. So very important thing that this is the phase change between liquid to a gas. So, and the temperature at which a pure liquid boils, it's called as its boiling point. And the very important point which should be understood here very clearly, that every pure liquid has its own unique, sharp, fixed boiling point. So we continue to another thought-provoking question, that what happens to the particles of a liquid that is heated until it boils. Now this diagram will explain you all the changes. Like this is the phase in which this is water molecules, models are taken, and these are small water molecules, and they are quite closer to each other. They are in form of layers as they are provided with heat energy. they will absorb heat energy from the flame. So what they are doing, basically they are absorbing heat energy, and this heat energy is increasing their kinetic energy. Now a stage comes when the kinetic energy is overcoming or increasing then the interbinding forces of the water molecules, and that's the stage when liquid particles escape from the liquid phase to the gaseous phase. You see, the particles are becoming independent and they are just leaving the liquid surface and they are becoming the gas now. So the change during heating is just the absorption of heat energy and to break down the interbinding forces of liquid particles. So how we can predict it? A sample which is given in your textbook is carbon tetrachloride. Carbon tetrachloride is almost similar to water, but this is non-flammable organic liquid and it's a bit oily. So this is not water, this is carbon tetrachloride. The formula is CCl4. Okay, it's a liquid. So this time we will understand what will be the changes of temperature when carbon tetrachloride boils up. Again, we begin with the heating. As we continue heating a liquid, the temperature is rising. The temperature rises up to a level. For example, this is a stage W, and from W to point X, the temperature is rising, and this is due to the gain of kinetic energy. And what is going on? Heating is going on. Okay, now between X to, suppose this is point Y, during this heating, the heating is on, but the temperature becomes constant. Temperature change is 0. So at this stage, the liquid particles are absorbing enough kinetic energy to overcome the binding forces, and this is the phase where the state of matter is changing from liquid to the gas stage. Now this is the stage from Y to onward Z. Now this is the stage when the particles of the gas are in the gaseous phase and they are absorbing much heat energy, so the temperature is rising. Now how we determine, suppose we are performing some experiment in the lab and we have taken the readings, the temperatures versus times. So when we'll be plotting the values on the graph, we will get to know that when is the temperature not changing. So if we are performing this experiment for carbon tetrachloride, we will observe that when 77 degrees Celsius come, the temperature remains constant for a while. So the boiling point for the chloroform will be 77 degrees Celsius. So this is how we will learn the changes of physical state. Now you have to write, you have to check your understanding by writing the answers for this video lesson, that what is freezing, what is the change of intermolecular forces during freezing, and what is the difference between evaporation and boiling. Oh, I forgot this. So let me explain you that whenever the liquid, suppose this is the beaker and the liquid particles are in the beaker, for example, at any temperature, some of the surface particles of the liquid will get energy and they will leave the liquid phase to the gaseous one, and we call this process as evaporation. So evaporation is a cooling process which goes on all the time, but boiling is the process which happens at a sharp melting point. So boiling is something when all the liquid boils up and leaves the liquid phase, and boiling point is a constant for any liquid. So evaporation goes on all the time. The speed of evaporation or the rate of evaporation can be high, can be low during different seasons, but boiling occurs at a sharp temperature. So this is how you have to draw a column and writing differences between evaporation and boiling. You can also find more statements and facts from the net, from your textbook, to write the answers. And the last one is draw the heat curve of water. So I have given you something unseen which is not given in the book, so you just think about it and revise the lesson, read it from the textbook, then you will be able to write the answers, inshallah. I am leaving you with the hope that this lecture will be really worth to understand the topic and to give the answers for the questions from the past year papers from the topic. Okay, God bless you. Khuda Hafiz.